Hello, everyone. I'm Greg Weaver. Welcome to the Audio Analyst. Pardon me. By the end of 2019, once it had become quite clear that the COVID-19 epidemic would preclude most, if not all, audio shows planned through the spring of this year, Liz Smith, Axpona's event director, reached out to me to see if I would be interested in helping her develop some video events for the Axpona website. In no time at all, we had a few seminar-type events planned, the first of which occurred on January 13th and saw me moderating a loudspeaker designer roundtable featuring 4 of my industry friends, all highly gifted designers. Those presenters included Andrew Jones of ELAC USA, Leif Swanson of Von Schweikert Audio, David McPherson of Studio Electric, and Gayle Sanders, who, though he was representing his latest venture, Icon Audio, had been the driving force and co-founder of MartinLogan Electrostatic loudspeakers in the early 1980s. When following up with everyone after that event, I asked Gayle if he would have any interest in talking about his latest venture, discussing the Icon Image 1 system, as well as sharing the Martin Logan story here on the channel. To my great pleasure, he thought those were wonderful ideas. The Icon discussion dropped here on the channel on August 15th with episode 55, a conversation with Icon's Gayle Sanders. Today, I am proud and honored to be able to bring you Gayle's fascinating and personal recounting of the creation and subsequent course of one of the most distinctive and exceptional loudspeaker companies in the history of our industry. Now, before we begin the conversation with Gayle, let me set the stage, as it were, just a bit. Most of you in and around this industry know that the name Martin Logan was created by taking the middle names of the co-founders, Gayle Martin Sanders and Ronald Logan Sutherland. But what about the motivation that drove Gayle to create one of the most iconic brands in the history of our industry? What had come before? Well, it was Peter Walker, the founder of Quad in London in 1936, who brought the first electrostatic loudspeaker to the public. Interestingly enough, Quad was an acronym for Quality Unit Amplifier Domestic. Yeah, don't ask. But in 1957, they released the Quad Electrostatic Loudspeaker, or ESL, which, while commonly referred to as the ESL 57 because of the year of its introduction, never actually bore the 57 in its moniker. Now, this first production full-frequency range electrostatic loudspeaker sold for about 52 pounds, or about $80. At 34 inches wide by 31 inches tall and some 10.5 inches deep, the operation principle was simplicity itself and was actually based on a patent granted to Edward Kellogg from General Electric back in 1934. Essentially, a thin sheet of plastic treated with a conductive coating was suspended between 2 perforated metal plates. The plastic diaphragm was charged to a high voltage and was driven into motion by the varying audio signal voltages applied across the perforated metal plates. Now, while the Quad soon became renowned for its sonic transparency and very low distortion, these very desirable traits were more than offset by its extreme directionality, its very moderate power handling and bass extension, and its novel electrical characteristics, we'll call it, which could render some amplifiers unstable, often resulting in damage to either the amplifier, the speaker, or frequently to both. Arthur Jansen had come up with a system that used a pair of panels, each 6 feet tall by 2 feet wide, and about 3 inches thick, that incorporated a number of different sized ESL drivers covering differing frequency ranges about the same time as Peter Walker introduced the Quad ESL. In 1961, he licensed the design to Henry Close, Malcolm Lowe, and Joseph Hoffman, the founders of KLH, who presented it to the world as the KLH Model 9, with an introductory list price of right about $1,000 a pair. Now, they too were very directional and couldn't play very loudly, but they could play noticeably deeper than the Quad. Arnie Nudell and his partner, the late John Ulrich, a man I'm honored to say became a friend, set the audio world on its collective ear with the introduction of the Servostatic 1 from Infinity in 1972. Now, this remarkably advanced tri-amplified system consisted of a pair of 2 panels, each comprised of several fairly large mid-range radiators and some narrow, vertically mounted RTR electrostatic tweeters. It also featured a servo-controlled 18-inch woofer module with its combined electronic crossover and a switching bass amplifier, both of which were John Ulrich's contributions. The system sold for $2,000 without the necessary separate mid-range and treble amplifiers needed to complete the system. They were amazing when they worked, but the original models suffered dependability issues, which were ironed out eventually. Now, Jim Strickland had found a way to address the high voltage breakdown, or arcing, that had been so common with ESL designs to that point, and introduced the Acoustat X also in 1972. Standing 48 inches tall, some 28 inches wide, about 19 inches deep at the base and a little over 7.5 inches deep at the top, the X, while it did use 3 panels per side, angled for horizontal dispersion, all 3 panels electrically functioned as one, and they were all driven full range by a specially designed push-pull tubed output stage Strickland called an integral servo-charged amplifier. They too were plagued with dependability issues, especially that dedicated amplifier. Now, at this point, it was now the late 1970s, and Gayle was working in the industry as the manager of an audio store. Let's pick this up with Gayle and let him take us on this incredible journey.
Hello, everybody. As promised, Mr. Sanders has been kind enough to join us once again here on the channel. And again, as promised, we're going to talk about the fabulous run that Martin Logan brought starting in the late 70s through they're still in business, although you're not at that moment.
Yeah. Absolutely.
And I actually covered a subwoofer launch they did for the Absolute Sound I guess it was about 3 years ago.
Mm-hmm.
Yeah. But so I would love to start, if we might, sir, with your youth, how you got into it. Now, I've read that there was an enlightenment moment where you heard a system that belonged to the friend of your father's that was Macintosh and Thorns and Klipsch. Can you go into that a little bit for us?
Well, yeah. I mean, I was a musician, and I played professionally from the age of 13, playing folk music. And
I didn't know that.
Yeah. Mm-hmm, yeah. And so I loved music from the very beginning, but I had technical background. And even back then, and then, we've been listening to our little AM radios.
Yeah.
Right. You go to sleep, you turn that AM radio on and you're listening to the latest rock and roll, wide wall of sound, whatever. We all put ourselves to sleep with those little AM radios. And I went to this friend's house and he had this system that we just talked about, clip speakers and Mac amp and all of that. And I can't remember exactly what the music was, but I just remember going, oh my God.
About how old were you at that time?
I was 17, 18.
Oh, wow.
17, 18. Uh-huh.
Yeah.
And just the power, the dynamics, the clarity, the precision, the real show was right there, right in front of me. And that was it for me. I want to recreate sound. I want to recreate that event. And that was an epiphany, and it still is with me today, right?
I totally get that experience. Yeah. That's very cool. Now, So you went off to college, and what was your field of study in school?
Architecture. Architecture. And then I met I apprenticed for a while, and then I found out I didn't like it. So I had 3.5
That happens
years
often.
and it was great because I got the technical stuff. I got the calculus and the physics and all of that. But it was I could see that it wasn't for me because it was like 2 or 3 bosses and a bunch of guys at a drafting table back
Yeah.
in that day.
Yeah.
And so I got into journalism and advertising.
Wow.
And learned to really design graphics, a bit of copywriting, all of
Right.
that. And that all stead me, and so graduated in journalism.
Wow.
Yeah.
Well, that's
Yeah.
great. All right. So now,
Yeah.
once you left school, you ended up selling at the David Beatty
Oh.
studio or stereo there in. It
Got
still
it.
was in Kansas City.
Right, and I was just I tried my hand at journalism, which ended up selling advertising.
Oh, okay.
And I did not like that at
I'll
all.
bet.
And I
Yeah,
saw
I'll bet.
this ad looking for salespeople, David Beatty Stereo. And I just, on the spur of the moment, went ahead and applied, and was a life-changing
I
moment.
can imagine.
Yeah, yeah.
Yeah.
And of course, David Beatty Stereo was one of the premier audio outlets back in that day. So they had everything,
Sure.
Magnaplaners were coming out, Audio Research was coming out, Macintosh, Bozak, all JBL, Stax, all of the top end products. So I was able to experience that. And of course, we also had a cabinet shop. So even before
Oh,
custom
wow.
install was even a thought in most audio retailers' mind, we were installing large installations of like stacks of Macintosh with rosewood cabinets, and installing large JBL systems. We were using people's garages for the infinite baffle, and
Yeah.
then we would mount per channel 4 JBL 15-inch woofers in the wall for each
Wow.
side, and then some I think it was the Harsfeld lens and the 075 ring radiator. So that system was like incredibly efficient and very dynamic. And
Yeah.
it could bottom in because it was using a garage for the
cabinet, for the
yeah.
enclosure. God.
So I had an exposure to some really significant designs
Yeah.
back in 1970.
Yeah. Now you mentioned Stax headphones, and you and I discussed this. I had a pair of the Lambda Pros back in the day because they were.
Yeah.
I mean, to that point, they were probably the most successful electrostatic drivers out there.
Oh, yeah.
Let me set the climate a little bit. We had, of course, Peter Walker's quad the quad ESL 60 or 57s that came out.
Right.
And I mentioned to you that when I heard the Monolith the first time, it was like, oh, that's what he was trying to do. But that was in 67. Now in the early 80s, he came out with the 63, which was a much improved version. But also before there was Arthur Jansen, who was still at he was working at KLH, and he did the KLH 9s, which were each side was 2 panels, right? There was a mid treble and a woofer panel on each side.
Right.
And then I think it was 81 or 82, Jim Strickland brought out 72.
Yeah,
Jim Strickland brought out the
earlier.
Acoustat X.
Absolutely. Strickland came out with the Acoustats earlier. Yeah.
That Acoustat X. And his point, I guess he was trying to address that high voltage breakdown issue. And one of the integral parts of what he was doing was that integral servo charged amplifier that was part of the Acoustat X. So that was what was out there when you decided it was time to do it differently.
If I'm right, there were a couple of other products out there
Okay.
that really inspired me and showed me the direction I did not want to go.
Okay.
So yeah, Jim Strickland had done a great job. And he had solved a lot of things, and he had kind of changed it up a bit. He used this matrix up, which I think were like fluorescent light diffusers, and then he would string Teflon coated wire on them for the electrodes, and that solved that sparking and arcing issue, which was a big problem because basically with electrostats you're trying to control a lightning storm, right?
You're driving a giant capacitor. I mean,
huge, 8,000 volts differential sitting there within an eighth of an inch of each other. And so you have to really pay attention to your conductive surface and your insulation on your stators and a whole number of things. And so Strickland kind of solved it that way. But the system, again, was challenged in terms of bottom end, challenged in terms of efficiency, and challenged in terms of directionality.
Yeah.
Head and a vice kind of a listening experience. Only one person could listen to it. And actually, earlier than that, Greg, early 70s, Infinity, where Infinity really got their start was with an electrostatic. It was called the servostatic.
Servostatic, yeah.
Right? And it was, I won't bore you with all the wonderful stuff it was, but it was advanced.
Yes,
it was a triamped system with a downloaded 18-inch subwoofer that was servo controlled, which was unheard of at that period in time.
We were talking about that. My buddy,
servo control subwoofer satellites. That was way before anybody thought of that. And then they were using the RTR tweeter for their extreme top end, and then they built their own mid-range driver, which worked extremely well for about 15 minutes. And then that thing blew up and arced and sparked and whatever, but it sounded great while it was.
Oh man.
And it would, but when I heard that was the same kind of revelation that we talked about earlier. For the first time I experienced audio, when I heard that was like, holy cow. I mean, and we had this big setup, we had this, a bunch of single guys, and we had this huge living room down near the plaza, and we built these giant subwoofers and JBL systems, and then we brought the Infinity Servostatic in there, and that was in the days of Carver, Carver amplifiers and Threshold and Audio Research, and so we put together this Infinity system, and I could not believe the transparency and the detail and the dynamics that were coming out of this. It was a whole step. It was not a subtle difference. It was a leap in clarity, precision, detail, all image specificity, just that you are there experience. And it did it on this huge scale. And Arnie Newdell and his team just really knocked it out of the park in terms of performance. And unfortunately, it didn't live long because they just couldn't keep them working.
Right.
And
we were talking about my buddy John Ulrich, who had been a huge part of that. He and Arnie had worked together, and I guess John built the Swamp, which was the first switching amplifier, and he built that servo control for the subs.
These guys were just geniuses.
Way ahead of the scale. Way ahead.
And so that was really I saw God, that was really an experience. And that stayed with me for quite some time, but I didn't dare take on. I was designing dynamic loudspeakers and floor monitors and DJ systems in my spare time, and I had a little shop downstairs. And while I was selling in the day, I was also building products and designing products in moonlighting and building for other companies, primarily for bands and disco systems.
Sound reinforcement stuff, right?
Yeah, using my little architectural design work.
Yeah.
And but then, now I had changed by that time. I had put another shop together and with another individual, and we now had our own retail shop and beverage. Harold Beverage came along.
Yep.
Remember the beverage?
Yeah, I do.
Yeah, and a beverage had he attacked the dispersion problems. He had a flat panel, but then he used this big lens to shape the wavefront, basically delaying the, problem with a flat panel transducer is all the small wavelength frequencies, when they leave it, then they line up and you get a very narrow dispersion.
They beam. They really beam.
And so if you have a wide panel, then all the high frequencies only one person can hear them. They're just like a ray. They're very directional.
Yep.
So Harold Beveridge created a lens that delayed the pathway for the frequencies that were farther off axis than those that were on axis, creating a bubble of sound and dispersion. And he had some other technical things that he was doing that I found very interesting. He put the signal on the diaphragm and the bias charge on the stators, which was very different. Most people would drive the stators and had a bias charge on the diaphragm, and that worked to an extent. But he had degradation problems too. His systems also, over time would degrade. And also, you could hear the lens. You could hear the lens distortion. So there were some issues, but it was still really a very, very good system. And it was about that time that I thought, I'm going to try and just see what I can do and build an electrostat. Now, I don't know if I'm going
about 78.
Huh?
This was around 1978 or so, right?
1978. Right.
Okay.
Yeah. Yeah. So around 1978, then I started working on developing an electrostat, and that was about a 3-year process. And during that period in time, that's where I met Ron, because Ron. I mean, I had engineering background. I didn't have electrical. I had all the mechanical engineering that required, but I didn't have a lot of electrical engineering. And Ron came with electrical and physics degree.
Yeah.
Masters.
Well, he dealt with like the transformers, power supplies, things like that initially. No?
Yeah, he helped me. Yeah, he helped me design transformers, power supply, testing equipment for all the high voltage issues and all of that. Yeah, he was great. Yeah. So I set off, and I had the mechanical transducer pretty well developed by the time I met Ron. And I said, Ron, I still need to develop a power supply, transformer, filter circuits, et cetera, et cetera. And he said, well, I'll work on that with you. It's what a great idea. Let's give it a go. Let's give it a try. And so every night, after work, it was Ron and I tinkering away, blowing up power supplies, electrocuting ourselves, So we were trying to figure out how to insulate the metal panels. So basically, an electrostat, as you know, is a stator in the front, a stator in the back, and a diaphragm in the middle. It's a sandwich, and you have this perforated metal in the front. As a matter of fact, here's a lovely little thing.
There you go.
So this is the stator material right here. Yeah. And so it has to be coated, perfectly insulated. This metal has to be perfectly insulated, uniformly, 100%, to withstand upwards of 10 kV in close range. So it's an almost impossible challenge, particularly perforated metal, because when you punch it, you shear it, and you create little hard edges and little nirnies, and that's exactly where the insulation pulls away. And so it's an incredible challenge. But at the same time, what had happened was that NASA was wanting to bring all of their new materials, technologies, that sent men to the moon, and now they were trying to commercialize all of this technology. And so they were eager. They would talk to anybody if they had a potential application for their new materials, as a Teflon, ceramic coatings, optical coatings, semiconductor surfaces, insulations, adhesives, all of this cool stuff.
Wow.
So now, this is back in 1978, remember, so there was no computers.
Right.
There was no mobile phone.
Correct.
It was just a standard, dial, circular dial tone. And I had this desk in my garage and a book called The Thomas Register. Do you remember the Thomas Register?
I do. I actually do.
And it was this big, thick green book, as I recall. And it was all of the manufacturing processes and materials that were available in one book.
Yes.
It's like the Bible. This was awesome. So here I am with a yellow notepad, a pencil, and a Thomas register and a dial-up phone. And every day I'm just dialing for technology. And so I would call NASA Aerospace. And I'd say, I'm Gayle Sanders, Martin Logan Research and Development. We're researching a thin coating substrate for electrostatic transducers. And do you have an engineer that might know something about that? And invariably, they just put me back to the engineering department, and I'd start talking with these guys, and there'd always be somebody going, "Oh, you're working on an electrostatic transducer? That's cool, and I think we've got something here, and whatever." And over time, then I would get these wonderful materials, insulations, adhesives, etc. That's what the technology needed.
Right.
Electrostats were known for being the most accurate way to reproduce sound, but they also were known for blowing up and arcing and sparking and degrading. And it was and I realized, it wasn't magic. This wasn't an unsolvable problem. This was a materials problem.
It's an engineering problem. Yeah.
It's an engineering problem. And really not so much engineering, Greg, as it was materials application.
Okay.
Because the engineering was pretty straightforward, right?
Okay.
Low mass transducer, 2 stators, get them correctly spaced, get your transformer correctly with the right turns ratio and let it go. And the thing's inherently linear.
Yeah.
And it's inherently low mass if you've got the right transducer. So if you put the right materials in play, you can solve this problem. And so I just got after it. And one by one, and there were hundreds of problems.
I'm sure.
And one by one, I just kept knocking them off: the insulation, the adhesives, the surface conductivity. And I could go into detail on all of those things and bore you guys to tears. But we started really working our way through and solving those things with these wonderful support from this new technology that had come from all of the output from the space race.
I can't imagine a 2 or 3 person company having any success like that today, trying to get through to such engineers. It was a different time.
It was a different time and different.
Yeah.
Yeah.
And it's so exciting that they were so anxious to help you.
Yeah.
I think that's just amazing for us in particular.
At the right time, and my fingers were doing the dialing.
Yeah. Man. So by 79 or so, no, by I guess about 80-ish, you had a prototype.
Right.
And this is quite the story. I mean, it's been in Absolute Sound. It's been around that this was the 5 minutes after you turned it on, everything goes up in smoke, including your beloved DH200 amplifier, right?
Yeah, by Hafner. DH200. Yeah. Well, and you probably I hope you have an image of it. It's a beautiful thing to behold. It's a real proof of concept. I'd sprayed Ridarc on it, I found some perforated metal, and I was using some plexiglass strips, and I'd use contact adhesive to put the plexiglass strips together. And I mean, it was really a Rube Goldberg thing at best.
Wow.
And I mean, and we had it in my living room naturally, and we had this poor thing propped up we were in such a hurry, we didn't even build a stand. We just took a stick and we propped it up on a stick and started clipping all of the wires together and hooked it up. And, we put the tone arm down, and the beautiful tones. Joni Mitchell, both sides now came out. Unbelievable. And, Ron and I were crying. I mean, we were just like beside ourselves, just like, oh my God. But it was been 3 years.
Yeah.
Of hard every night at this.
Yeah.
And but I hadn't really solved all these problems. This was just a proof of concept, right?
Well, that's where I was going with this. This was an amazing proof of concept. It gave you guys the confidence to know you were on the right path.
We were on the right path.
Yeah.
Right. But it didn't last very long.
Yeah, what happened when you turned it up?
Well, we were crying and we were jumping up and down. We were like, "Whoa, this is fantastic!" and all of that. And and I said those famous words, let's turn it up. And we turned it up. And I mean to tell you, kaboom! I mean, just a lightning storm went across that transducer, and then there was dead silence and a puff of smoke, coming up off of my beloved transducer, and a puff of smoke coming up from the Hafler DH200 as well. I mean, it that was it for the project for a while.
Well, you guys pulled it together, and over the next couple of years, it was summer CES of 82, right?
1982. Yeah.
That you showed you guys got an award for a static demo, right? I mean, you were just showing what it was going to be like. You got an award for that. No?
It was supposed to be a working product. And I knew it would work. I mean, I had the prototype working at home.
Okay.
And I had the design and the product packaging done.
Okay.
But I had not integrated the prototype into the packaging when I applied for the Consumer Electronics Best of Show Award.
Right.
It was supposed to be a working model, and I cheated a little bit, but but I think we have to do that. If you have to, it's got to be realistic.
Sure.
You got to pull yourself up into that as a startup, and I knew that I could get there in time, and you sure did.
Well, 83, you actually showed the monolith, correct?
Yeah.
83 was.
Well, I think it's something like it. Was it 83? Was it? I mean, it was very shortly, 6 months. It was very shortly thereafter. We got the award, and maybe 83, 82, 81, 82. Anyway, they're very, very shortly after.
Close, yeah.
We a working model of that very same. Yeah.
Now, the monolith was one of the first hybrids I can think of, because you actually used a dynamic woofer below 100 hertz,
right,
and then your panel above 100 hertz.
Well, this is the inspiration of Infinity.
Yeah.
I was not about to have another inefficient dipole as my first offering.
Makes sense.
I wanted something that had a tack that would get up and really go, and yet still had the electrostatic clarity and precision. And I knew that because just the physics, the raw nature of the physics, a wavelength doubles every time it goes an octave lower. And a wavelength at 100 hertz is a 10-foot long wavelength.
Yeah.
And at 50 hertz, it's 20. And so to get a dipole
to move like that,
to operate, where that air is just moving back and forth from front to back and decoupling with the room, you're asking it to do an impossible. The physics is just unworkable.
Yeah.
And so, and I also knew that if you get to 100 hertz, and then you transition, that's a big wavefront. So the subwoofer's kind of omnipresent in the room. And so that was the fundamental principle that I went after. And that's why I went after hybrids from the very beginning. Sure. Even though my next offering was a full range ESL, I knew that really to launch, I wanted something efficient and effective and powerful. And that was why I chose hybrid. Had to be. It had to be.
Well, and I got to tell you, one of the things. Now, I didn't get to hear it until about 85. Is the first time I heard the speaker. But what struck me the most about it was, and even since there have been companies that haven't been as successful. What struck me about it was the transition point was not apparent. I mean, it didn't. I mean, I've heard later speakers where people tried to mix horns with woofers with dynamic drivers or panels with dynamic drivers, and the woofer was extremely slow and the timing was behind everything. But what blew me away about the original monolith, the first time I heard it, I was like, Gayle, it was damn near seamless. I mean, I couldn't really tell that there was a transition point, and that's what knocked me out about them. We had that magic of the mid range that you get from ESLs, because I've had ESLs. I spent a long time in 8-foot tall ESLs, but dude, that thing was
ESL land.
Huh?
ESL land.
When it's done right, there's a magic that's really hard to deny, as you well know. Now, you got the idea. Now, you wanted to build what ended up being called the curvilinear system, which so, and what we're talking about is most electrostatic panels are flat between, there's a sheet of mylar or something between two stators. But you wanted to curve
or you have two panels where you have a crossover point.
Right. Yeah. Like the KLH9 was doing
like the KLH9s.
Yeah. But you wanted to get the timing and the launch and the coherence all from the same panel, which is where the CLS came from. Now, about 85, I think that was about the time that David Hafler purchased the Kustat and took it over. And it was about the time that Ron left. He went on to open Sutherland Engineering.
Right, that's right. Yes.
But you were getting ready to do this great CLS. Let's talk about that.
Yeah. Well, with the monolith and that transducer, I wanted a high efficiency transducer, 90 dB minimum. I wanted large bandwidth. I knew I had to get that thing down to 100 hertz.
Yeah.
And I knew I had to go hybrid because it had to be efficient.
Sure.
So I wanted efficiency, I wanted wide bandwidth, and I wanted dispersion.
Well, and those were all the problems with the earlier models, like the quad and things. Yeah,
I had to solve all of that before I thought we had a real product.
Yeah.
And that was the monolith. And then once we launched with that, and it was expensive.
I'm sure
we were successful, but still, it was an uphill battle as a company.
Yeah.
Financially. And so in the back room, I mean, and in the early days, we hid the transducer because it wasn't pretty.
Sure.
And the diaphragm was somewhat opaque. But as we became advanced in our technologies, our adhesives, our support mechanisms, our diaphragm coatings, I could see this is a beautiful transducer. You could see right through it. And I thought, what if I could have one transducer reproducing all frequencies and it would be see-through? And that became the CLS. That became the working underlying thinking of that. And of course, I didn't have any money. So I had to use the same metal that I was using for the monolith.
Okay.
For that transducer.
Okay. Interesting.
Yeah.
Now, that was the CLS was about 86. It was a reality, correct? Right around there.
Right. That's right.
Now, dude, anybody who's ever seen one will never forget it because, Gayle, regardless of how wonderful they sounded, they were simply gorgeous to look at. They were as artistic a statement as they were a musical statement, in my opinion.
Yeah, that's pretty.
And they were pretty successful too, right? I mean, you did
pretty well. They were incredibly successful.
Yeah.
The CLS1 was very successful. Now, quick story.
Yeah.
So I built, I think maybe I've told you this one before. But for those of you who haven't heard it, you're going to have to hear me. Yeah. Anyway.
You want to hear it, Gayle? Tell us.
You're going to hear it again. Yeah. Yes. Those of you that have heard it. So I built the CLS. We launched it. It was a every night thing. Another one of those every night in the back room. Blah blah blah. Sure. 2 years, 3 years, just working away, and finally figured it out. And we launched it. It was an overnight success, and it was fantastic. But from my retail experience, I wanted to make sure that this thing was serviceable. I didn't want the customer having to send the product back, or the dealer having to, box the thing up, send it back, and deal with all of that really hassle if there's a service problem. And I knew I was on the screaming edge because it was this technology was,
so new. Yeah.
And very new. And I didn't know if everything was going to be that reliable. And sure enough, we got about 200 pairs of speakers out there, and every one of them started to rattle.
The diaphragms changed.
Full curvilinear diaphragm, once it settled in, would rattle. And I mean, this was the end of Martin Logan. I mean, it was 12 o'clock at night. I'm crying, staring at my factory walls, thinking I'm going to have to shut the door tomorrow if I don't fix this. And it was right at that very moment. I mean, right at that moment where I'm just like, this is it. I'm having to. This is the end.
Yeah.
And I had a transducer over in the corner that I'd been working with about a month before that had some promise, but it had flat panels on the perimeter with an arc in the middle, and the sides were flat.
Okay.
And I'd abandoned it I'd rejected it because, we talked about flat panels, radiating,
You wanted a perfect,
and I wanted this perfect curvilinear transducer. And, but I thought, what have I got to lose? Let me build this thing up. Let me try it out. And so I kind of did a little did the physics on it and tested, the different resonant characteristics, blah, 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 and then set off and built this panel and put it in the frame. And by God, it worked. I mean, this thing worked. It had deeper bass, powerful, for a dipole.
Sure. Yeah.
Powerful bass, good power handling, and I could just hit it as hard as I wanted to, and it was just going. So,
now the original issue was a deformity of the original. I mean, what caused the change in the diaphragms that caused that resonance? Was it
the diaphragms would start to cave in on the sides, and then hit against the stators?
Okay. Gotcha. All right.
And so by having flat panels, I could control exactly the position of that panel, and I could get higher excursions.
Sure.
So the next morning, I just said, okay, everybody, here's what the deal is. We're building these new stat panels. And I can't remember what the height, width, girth measurements on UPS was, but I'd struggled so hard to build a service box because this panel was big. It's 2 feet by 4 feet.
Yeah.
And UPS, I wanted it UPSable. I wanted to be able to just, if we had a problem, we could just send them out there. And I designed it so you could snap the panel out, unplug it, and snap a new panel in.
Wow.
And because I just wanted it field serviceable, and I
Sure.
wanted a knowledgeable salesman to be able to fix it in the field.
It's a great idea. Not everybody was that thoughtful, Gayle.
Yeah, but I knew what a hassle. Having my retail background, that experience taught me, you don't want to do that to a retailer. Right. And so I really tried to make everything field serviceable and testable by a knowledgeable salesperson. And boy, did that come in handy.
I'll bet.
We were able to just blast out those panels and fix everybody's problems. And I went from the pariah of the industry to like, we're all in this together. And, that became, when Martin Logan became synonymous with taking care of your customer.
Yeah.
Solving problems.
Yeah. Wow. It was a spectacular product, Gayle. There's no question.
And it was. I mean, boy, Greg, they were finicky to set up, but when you set them up,
when they were right, oh my God.
Yeah. Oh, that was holographic.
Oh, absolutely. Their three-dimensionality and their clarity, especially their transparency of the soundstage, was unbelievable. That's
and that became, by the way, and I'll put a little plug in for Icon. That became part of the standard. The standard that I set for Icon in terms of clarity and precision was the CLS in terms of that.
And folks, if you haven't seen that episode, go back and watch it because it's a great speaker.
Yeah, go back and take a look at my new
Now there was a cleverly named sequel to the that came the following year, like 87-ish, and was it introduced to replace, or was it introduced because you felt it was just a better product and it was time to do it?
Well, it was introduced because I knew that the CLS was one customer and that the hybrid was another customer.
Sure.
The CLS was competing against Magnaplanar, Apogee, a number of other planar, acoustat planar companies.
Right.
The sequel was a high efficiency curvilinear hybrid. And I knew that if I cut that panel in half and went with a more moderately expensive. I mean, the monolith had, solid rails and all of this stuff, and if I just streamlined all of my processes, I could get down to a less expensive price point. And so that was the exercise in my head was, what if I split? Could I get a good sounding product if I split the monolith in half? That's the sequel to the monolith.
Yes. Well, and I remember those were pretty darn popular, pal.
That was.
I don't know how many you sold, but there were. I mean, I saw those in a lot of houses. I mean, I saw a lot of people that actually owned those. They were pretty popular.
The CLS put Martin Logan on the map. The sequel made us a real company.
Yeah.
That's when, boy, man. I mean, we were rolling.
Yeah,
we were rolling.
You were talking about.
There were a lot of bumps. There were a lot of bumps.
I'm sure.
I
knew there were.
Bob Carver had to loan me money.
We talked about this, yeah.
And I built the sequel originally for Noah Lee.
Oh yeah.
But we couldn't come. Shocker! We couldn't come to an agreement. And those of you who know Noah Lee of Monster Cable, genius and a workaholic, brilliant man. He and I couldn't come to a business agreement.
Well,
I said, I'm just going to do this myself.
Sure. Well, you talked about the sequel being a choice to try and do something very affordably by cutting the monolith in half. I think that is an interesting segue to what I remember as being a really amazing and affordable product, the Arius. That was a few years. That was in the early 90s, 91, 92.
It almost became my favorite product because it was just so cute.
Yeah. It was beautiful, and I bet you sold those like popcorn comparatively.
Oh yeah, I mean, by that time, we'd had to raise the price on the sequel. Sequel started to escalate up in price, and we were well entrenched. We had a tremendous dealer group, and we were in 45 countries. We had 45 dealers worldwide. So we were well established by that time.
Yeah.
And so the Arius, I was just surprised that we could get the performance out of it. By that time, I had now just a brilliant engineering team. I was still doing all the industrial design. The Arius was one of my last personal design projects. But after that, then I brought in an industrial design group, which I led, and then we came up with the Summit and the Prodigy and all those other products. Yeah. But the Arius was really the first mutual effort between me and Joe Voitko, who is still with a brilliant engineer with Martin Logan. And he and I just really pushed. And funny story. So Joe's typical engineer, fantastic, just brilliant, smart. And he kept coming up with different topologies and all of that. And I said, Joe, it's not cooking. It's not happening. I mean, it looks good engineering wise, but it's not magic. It's not exploiting the full extent of this electrostat. And he kept building these prototypes. So I kept getting so frustrated. I'd go into the listing room and I'd listen. It's just not there. It's just not there. And I'm thinking, what am I going to do? What am I going to do? So I got it. So one morning I went in and I said, okay, Joe, I've come to a conclusion. we're just not able to get there with the Arius, and we need to get there. And I know you can do it. But since we're having this challenge, either you have a choice. Either I'm going to go back to school and get my electrical engineering degree, or I can mentor you and you can become an audiophile. Which
Okay.
is, he goes, I'll become an audiophile.
Very cool. Very cool.
And so we then spent the next couple of months every night. I'd listen, we'd pull out the vinyl, pull out the CDs. I'd say, here's what I'm talking about. Here's stage depth. Here's real imaging. Here's focus. Here's pace. Here's all of these things. Do you hear it? Do you hear it? Until he got it.
Yeah.
Then he went back into the room, and bam, that became the Arius.
Well, and it was a good-looking speaker too. I mean, it really was.
Oh, it was, like I said, it was. I'd had all this time, and now it was one of the cutest. I mean, it was just cute. Darling speaker.
Well, and like I said, I bet you sold the hell out of it too.
And it performed.
Yeah.
I mean,
I knew a lot of those.
The best of Gayle and the best of Joe. All down in one little box.
Yeah, and I as I recall, they were about $2,000 a pair back in the day.
Right. Mm-hmm.
So not that was cheap by any means, but compared to
by that time, the sequel
big speakers I mean, it was a good price.
And it was really, each step from the monolith to the sequel to the Arius were minimum compromises in performance.
Yeah. Well, that begs the question: what led to the SL3?
All of the stuff that we learned on the Arius.
Yeah.
And so, and I can't remember quite why, Greg.
Sorry.
Probably because sequel 3 was kind of like, okay, whatever. So I think it just became the SL3 for that reason, but it was a sequel. I think, smaller footprint, smaller woofer chamber, more powerful woofer chamber, better crossover, better. And so it was really, it was not an evolution. It was a real change up.
But it could have been called the sequel 3. Is that what you're saying?
Yeah.
Yeah. Well, it was.
I'll have to go back in my foggy memory and figure out.
Well, it certainly was a good-looking speaker. I mean, I only saw them once that I remember anyway. But we
dropped the stat panel down. We kind of raked it back. The Arius had taught us that we can rake that panel back just a little bit, and we can lower that height. So the sequel was tall.
Yes,
it was like 6. I mean,
it was tall.
Yeah, it was. It was above you.
Yeah.
In the SL3, we were able to chop it down.
Well, it worked.
It was a good performance. Yeah.
Now, by '97, there was this. I never heard it. I have to apologize. There was a statement product, fittingly called the Statement. It was 4 pieces, right? I guess they weighed close to a ton. There were 2 towers with 12-inch woofers. I mean, this thing was massive. They were like $50,000 back in the day. And I've only seen pictures. Gayle, I never got to hear them, so I feel bad. But talk about what was that? Just one of those like, let's do let's just build the best one we can and let's see what it does.
Yeah, that was exactly it. And it went along with, and I think you probably have some images of that too, my lab listening room.
Yeah.
So the whole thing came. It's like, okay, if you think you've got the world's best transducer, Gayle, show me. And I've kind of said that to myself, let's go here, put it all on the table. What have you got? And so then I went back to Joe, and Joe had really become seasoned by that time.
Yeah.
I said, Joe, here's what the project's going to be. And we have to conform to these specifications. It's got to be flat down to 18 hertz. It's got to be infinite in power handling. It's got to cross over at 50 hertz. It's got to be dipole to 50 hertz, because I want that subwoofer to integrate at the size of the room, not at 10 feet or at 25 feet. And so I really put the challenge out there. And And so that became the statement. And I realized we had a couple of listing rooms at Icon, but we really didn't have the ultimate listing room where we could really flesh this thing out. And so I had purchased a house at the time, and it was on a very steep terrain. And so they had, rather than a standard 10-foot basement, this was a 16-foot ceiling basement.
Wow.
So I had a lower level that was 25 feet by 45 feet by 15-foot ceilings.
And we'll
then,
have the pictures up so people.
Yeah. And I was then able to really put in, at that point in time, we didn't have digital room control like the wavelet room control like we have at Icon. So I had all the room treatment and all the wall treatment and all of this. I went totally out. I mean, I worked with Bruce Brisson of ASC, and we put in a 2C 3D environment. We worked up all of the walls were non-connected walls.
Right.
We had put dampening materials within the walls to dampen them out.
Right.
Just on and on and on, to create as neutral an environment as we possibly could for this project. So it wasn't just the speaker; it was the listening room and the speaker itself. The speaker became we couldn't get down to 50 hertz at the volume. I wanted this thing to really, be able. I wanted 105 dB minimum at the listening level, at the listening,
orchestral concert levels. Yes.
Yeah, at the listener, not 3 feet, not
yes.
At the listener, uncompressed, no distortion, dipole down to 50 hertz, and that was kind of like the commandment. And we couldn't get there with an electrostat mid-range.
Yeah.
We could get down to about 100 hertz with our technology and really romp. But that last octave from 100 down to 50 hertz, we then integrated. Joe developed this dynamic dipole.
Okay.
And I can't remember what drivers, but they were extremely low distortion, high excursion. And they were like 8-inch drivers. And we had a line source of, 8, 9 of these in a dipole fashion.
Sure.
To handle that last octave that would transition us into 50 hertz. Then below 50 hertz, we had developed the balanced force subwoofer, which is the same thing that Porsche uses on their Boxster format engines, that when you have opposing woofers, if you have a subwoofer with a single driver and it's pushing forward, then all of that inertial force is the woofer, the cabinet has to counteract that.
Yep.
And so you have transient problems if you have a mono woofer driving forward, because there's just so much energy, so much inertial force going on. So Joe came up with this balanced force driver, the Boxster environment, where we're having two opposing drivers working against each other, and their forces counteract.
Right.
And then we developed these special ceramic panels that we built the whole system out of and embedded the woofers in. And so by the time we were done, we had 8 12-inch drivers per side in opposing fashion per channel. So we had 16 12-inch drivers handling that last octave.
Yeah. And I feel horrible. I never got to hear them, but the people I talked to said, "Oh my God!"
Yeah,
yeah.
It's just stunning. It was,
and it needed a big room. You weren't going to put those in.
It was stacks Lambda Pros down to subterranean levels. At beyond your ear's ability at compression levels.
Well, it loaded when you get like an organ that hits an 18 hertz key, the room just pressurizes like it does when you're in a cathedral when the organ hits that key. It's
it had that lovely, you hear so many subwoofers. You had so many subwoofers where, you hear that, but it doesn't, when you hear a 32-foot diapason organ pedal tone in a cathedral, it's not, it's this beautiful organic pressure front, and you know it. And that's what the statement could do, just effortlessly, effortlessly. It was just majestic.
Well, it was a spectacular speaker, and I'm so bummed I never got to hear him.
And so because of that, we started a training program, and we brought all of our key sales guys from all over the country, and we'd take 20, 30 of them and do a 3-day seminar, which would culminate in a dinner and a listening session.
Hearing that. Those lucky guys, dude.
Yeah,
well, now,
okay. That was great. I love that. I love that so much. So much fun.
I'm sure. Without trying to get too into areas that aren't any of my business, about how many of those were built, do you know?
Well, that's none of your business.
Okay, all right. I was curious.
Well, no, now during my period, I think there were maybe 10.
That's still significant, buddy.
But I think the guys they continued to sell a few after I was.
That's great.
Yeah.
Thank you for that. I was very curious. That was a pretty pricey product in its day, dude.
Oh yeah, I think it ended
That
up
was the late '90s, and they were $50,000 a set.
And I think it was $120K by the time it was all said and done.
Oh wow! All right.
Yeah, I think. Yeah.
Yeah. Well, yeah, you would know. So, all right. So.
Young timers.
By the end of the '90s, I think the next, and correct me if I'm wrong, probably the next product that I remember being important was the Prodigy. Does that sound about right?
Yes.
And what was the goal there?
We had really moved forward. I had this wonderful engineering team. I had now an industrial design group. Engineering team also had a mechanical engineer, and we'd made some really nice advancements in areas where, for instance, like for stabilizing the transducer, the electrostatic transducer, is this thin piece of metal,
right?
And 18 inches wide by 4 feet tall. And rather than having this giant wooden frame, we developed this like a guitar, truss rod in a guitar.
Okay, sure.
We developed this system where we could take a thin piece of metal, extruded aluminum, bore a hole in it, and then put a truss rod in it, establish a high level of tension, and that thing became solid as a rock.
Okay.
And so now we have this thin truss that we then could put the transducer in rather than this big, massive wooden affair. At the same time, we developed amplifier technology, driver technology, servo technology. We'd come out with our woofer program, which I'd spent 6 years with Joe working on servo-controlled subwoofers. Everybody says, well, Gayle, you need a subwoofer, and it just never was good enough.
Right.
And then finally, by the way, that's a great story, and remind me, and I'll tell you a little bit of. I'm going to deviate, if I may.
Sure, absolutely. Yeah, this is your story, sir. You
go. So we're building this subwoofer, and we're just not getting there, and we're not getting there, and we're not getting there. And we're using servo control, and we're using microphone-oriented acoustic servo devices, which they tend to go into oscillation and feedback like crazy. But Joe had developed this multi-level feedback network that was just crazy good, and he'd gotten really great signal to noise ratio, but we still weren't there, and it just made noise and it wasn't quite right. And one day, out of the blue, Paul McGowan called me, and we were just jabbering. Paul says, Gayle, you're doing this all wrong. He says, let me tell you how to do it. And he said, get this little up. He says, I'll set you up with this little device. He said it'll serve as it's a ceramic diode. It'll serve as an accelerometer, and it'll change voltage under stress, and it'll give you the information you need without all of this microphone feedback stuff. And then he gave me a supplier that we could integrate this into the woofer, and oh my God, it worked so well. And we just popped that into all of the work that we had already done on the amplifiers and the feedback circuit. And voila, all of a sudden came our first subwoofer project, and it came out. It was just tremendous.
Are we talking about the Descent?
The Descent.
Yeah, that was
Yeah.
That was such a cool
Yeah.
looking device too. You had
Yeah.
it was three tens
Three drivers.
around like 120 degrees
Rectangular.
apart.
It was a balanced force format,
Yeah, yeah,
right?
yeah,
Servo controlled.
yeah,
Yeah. And that thing, I mean, it worked.
yeah. They were pretty impressive. I remember those.
And we had stiff competition out there. I mean, there was some good subwoofer companies out there.
Yeah.
So we had to really hit a high water mark if we were going to live up to the Martin Logan tradition of performance audio. And so that became our subwoofer line. And then we did a lot of different products off of that. But that informed us as to what the next real sequel to the monolith should be, which was a powered subwoofer with this new truss-oriented stabilization system and an advanced transducer where we were able to get higher levels of efficiency, a little bit more bandwidth, and even more precision out of it than our traditional transducers. And that then became the Prodigy line. Yeah. Yeah.
Dude, it had to have been an amazing ride. I mean, I don't know. I just can't imagine how much fun you had to have had during all of that. I'm sure there were nights where you wanted to like shoot yourself, but I mean, I can't imagine. I mean, I remember it as the outsider looking in and going, what else is he going to do? Because this last one was pretty cool.
Oh, thank you. Yeah. Actually, I made a mistake. That was the Summit line. The Prodigy was kind of the intermediate. That was the beginning of my design department.
Okay.
And we had come out with a new design, and it was just lovely. I got another one of my horror stories to tell you on the Prodigy.
Yeah,
so
go ahead.
We had designed a whole new line off of the Prodigy. It was going to replace the monolith, replace the sequel, just a whole line using that industrial design concept.
Right.
And it was gorgeous, and it had some cast metal parts and, these rails and aluminum this and trim that and all of that. And by that time, I had my little industrial design department and production team and la, 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 la. And the problems with management are, you've got to develop systems of communication and all of that, and authority and accountability.
Right.
And what had happened is my design department had built this brilliant design, but they had just thrown kind of the documentation over to the production department and said, here, go build it.
Interesting.
And the prototypes worked just fine. And we got all these parts in. I had 100 people.
Wow.
Building.
Holy crap.
Nobody could build anything. The parts didn't fit.
Oh my God.
They were not manufacturable.
Wow. Because
I hadn't put a system in place where manufacturing had to sign off on product development's designs. That was a
steep learning curve there.
I mean, again, it was more of those sleepless nights. It was months of agony, reworking the parts, trying to find solutions, and really trying to find what was the problem. And the problem was just simply, accountability and communication. Yeah.
Lessons learned, sir.
Growth. Yeah, and we grew, but we learned, and we made it.
Now, there came a time about 2005 when Shoreview came into the picture, and and you left the company. And I'm curious if you would mind taking us on how that all went down and what caused it. I mean, I can't imagine you were just tired of everything, but maybe that was part of it. I don't know. How did it all go down?
Well, the decision to sell Martin Logan was kind of twofold. One, I'd been at it for 30 years.
Yeah.
And I thought, Gayle, you're a one-note guy here. Is there more to isn't there more to life? Whatever that means.
Time to enjoy it, maybe. Yeah.
And I thought maybe I should try something different. And there was an opportunity there. And we'd done such a great job. But I had a CEO there. I knew that I had topped out as a CEO. the size of the company was such that it needed a professional.
Right.
And that wasn't me. I'm a designer, entrepreneur. I love it. You know,
Yeah, you got to have your hands on. You got to be dirty hands. You got to be involved.
Yeah,
Yeah.
you get to 100 people. You get to the size that we were, and it takes somebody that puts departments together, has meetings, develops spreadsheets,
Yeah.
all of that stuff.
Yeah.
And I'm not that guy.
Yeah.
And
I get it.
and I went through 3 or 4 guys that couldn't cut it. And I found the right guy he was brilliant. And we worked together, and we just took the company together just to a whole new level, both in terms of performance and sophistication and all of that. And it was time. And he said, Gayle, I would like to sell, because he kind of wanted to move on. And I just, I kind of done my stint, and so I thought it was time for me too.
Sure.
And so we shopped around, and we found what I thought would be a really good group in Shoreview, in that they were strictly a financial company, and it wasn't a strategic play. At least I thought that. And that way, they wouldn't mess with my company as long as it performed.
That's always the hope, right?
That was the hope, because I had this wonderful team of people that knew what to do.
Yeah.
They knew what to do.
Yeah.
And it turned out that, then my CEO decided to leave. And so they had to find another CEO, and they brought another guy in, and it didn't work out. And in spite of that individual, my team just kept cranking out great product.
Yeah.
They didn't need, they just did an extremely good job. I mean, in hindsight, sometimes I kind of wish I'd kept it, because I love those people dearly. I love the group, but the team, the people, the family,
Sure.
the village that we had as much as anything. But it was time. It was really time. Yeah.
Well, I can't thank you enough for having made that trip, because dude, some of the most, look, seeing the CLS the first time was like, oh my God. Well, actually seeing the statement the first time was one of those like, whoa, because is it true that Stanley Kubrick's 2001 had something to do with the name of the look?
Well, certainly with the monolith. Yeah. Absolutely.
Yeah.
Absolutely. That was exactly what it was.
Yeah.
And Stanley Kubrick 2001. And as a matter of fact, one of the early first pairs of the monoliths, when Steve Jobs developed the Mac project, Apple.
Yep.
When he did the Mac, the whole Mac department, the pair of monoliths were flanking the doorway into the Mac project.
Wow. That's cool. That's cool.
Yeah, the monolith.
Yep. Mr. Sanders, I cannot thank you enough for sharing so much of your time and taking us down this road. People who know me know that the history of this industry means a ton to me, because I've been around it since the late 60s. And you were actually out there doing it. I was just a guy watching. I was a bystander. You took us on some great rides, and you are now too. I'm not trying to ignore Icon. That was a different episode. But I am so thankful to have your time talking about what was certainly one of the most iconic companies that's ever been in this industry. And I know they're still around today, and I have no qualms with what they're doing today, but it's not Gayle Sanders.
Yeah.
And like I said, I went to they had a subwoofer product launch in the Chicago area about 3 years ago, where I covered it for the Absolute Sound. And great people. They're still, they're really good people.
Oh, yeah.
The people I met.
Yeah. It's that Midwestern ethic, do what you say and say what you do. Yeah. Great people.
Gayle, thank you so very much.
My pleasure. And hello to all of my fellow audiophiles out there. It's been an absolute delight.
Thanks for taking the time, sir. We really appreciate it.
You bet.
We'll talk to you soon, sir. Good night.
Talk again soon.
Bye-bye.
What an engaging and gracious guest. Man, I hope you enjoyed hearing Gayle walk us through the history of one of the most unique loudspeaker companies in this industry, one that still pursues the most exceptional performance available from electrostatic loudspeakers to this day. Now, with that, if you are enjoying the content and information presented here, please click that subscribe button. Be sure to like and share links with your friends and on social media, and post comments and questions. Ways to support the channel may also be found at today's description section or at my website, theaudioanalyst.com. Thanks again for making the time to drop by and visit today. Please stay safe and keep the music playing. Till next time, cheers.